SLE, or lupus, is an inflammatory autoimmune condition that affects people all over the world. You may know someone with lupus, or you may have heard of some of the most famous people with this disease, such as Selena Gomez or actress Sally Hawkins, who I would point to, but my arm isn't long enough. Now, while lupus can attack any organ in the body, I'm most interested in the effects of this disease on the cardiovascular system. This is because young people with lupus are up to 50 times more likely to have a heart attack, and we don't know why. All we do know is that the blood vessels become damaged. But before we can work out why this happens, we need to make sure that risk is recognised. Therefore, the first part of my project involved analysing different cardiovascular risk calculators used by GPs. Now, these give you a score based on how likely you are to have a heart attack, and if that score is high, you'll be prescribed medication to lower that risk. However, when I compared the current calculators with a new one called QS3, if anyone's interested, I found that patients with lupus were being significantly underdiagnosed, meaning some had high risk but were being missed by the current system. We've since informed their GPs so that they can receive potentially life-saving treatment, and we hope that the NHS will take up this new calculator very soon. But so far, all we have are these calculators, and wouldn't it be amazing if we had new biomarkers to really personalise patient experience? Well, this brings us to part 2 of my project. Here I started looking at some things called endothelial microvesicles, which may sound a bit weird, but bear with me. So these are tiny particles that bud up from the surface of the endothelium, that's the inside layer of the blood vessel. They can be measured with a simple blood test, and I've actually found that levels of these microvesicles go up in lupus and are associated with inflammation and cardiovascular disease. So now we've identified our high-risk patients, we can start to work out exactly what's happening to the blood vessels. For this third part, I return to the microvesicles because we know they aren't just empty bubbles, they actually contain bioactive material which they can transfer to cells all around the body. And I was particularly suspicious of some things called microRNAs. Now, these are tiny pieces of ribonucleic acid that can actually affect gene expression. I then went on to show that there's a panel of these microRNAs that is increased in lupus and some that are decreased. Now, obviously, this feeds back into the biomarker studies, but also if I can pinpoint exactly which genes are being targeted, I can start to think of new drugs to target these pathways. So now I'm at the final stage of my PhD, and we know that every patient is different, but if we can combine our risk calculators with our novel biomarkers, we can use artificial intelligence to identify each patient's unique needs, providing precise, personalised medicine to keep everyone happy and healthy. Thank you.